Ball is thrown and it is determined that its height in feet in t seconds is given by this function. H of t equals 128 plus 32t minus 16t squared. And we're asked the question, what is the maximum height that the ball reaches? Okay, so we're following the 5-step process. First thing we want to do is identify variables. That's step 1. In this case, our variables are time and height. So I'm going to let t be the number of seconds passed. All right, so we're throwing the ball. T is the number of seconds that have passed since the ball is thrown. And then we have our second variable, h. Notice that h is given to us in terms of t, so h depends on t, so I'm going to write it as h of t. And this will be the height of the ball after t seconds. So, okay. So those are our variables, time, height. We need, step 2 is to find an equation that relates the variables. In this case, we're given that equation. The height function is that equation. So here's step 2. So I will work with this function in order to answer the question. All right. So to solve, remember the question is, what is the maximum height that the ball reaches? So to solve, let's think about that. Our function is a quadratic function. So the graph is a parabola. The leading coefficient is negative, so it's a parabola that opens downward. And we know a little bit more information. That constant, 128, is actually the y-intercept, right? Because if I plug in t equals 0, I will get 128. So I can sketch a quick graph of this function. So the y-intercept will be 128, and it's a parabola that opens downward. Okay, so what does that mean? Well, I'm trying to find the maximum height that the ball reaches. So we have our independent variable axis is the horizontal axis, and then height is the vertical axis. So the maximum height that the ball will reach, if we look at this picture, will be right about here, right? That's the value along the h-axis in this case that corresponds to the highest point on the graph. But also, what do we call that highest point? We actually call it the vertex. So if I find the coordinates of the vertex, the second coordinate, the h coordinate, is actually the maximum height attained by the ball. So that's what I want to do. That's how I'm going to solve it. I'm going to find the coordinates of the vertex and then interpret properly. I know that the first coordinate, it represents time. Second coordinate represents height. Okay? So the second coordinate will be the answer that I am seeking. So that's what we want to do. We want to find the vertex. Or we want to find the coordinates of the vertex. Vertex. Okay, so that's how we're going to go about solving this particular problem. So I'm going to go to the next page to do that because I don't really have room. So we have a formula. So it's negative b over 2a, and then our function is h, so h of negative b over 2a. All right, so right down here I'll write the function. So remember the function is h of t is equal to 128 plus 32t minus 16t squared. So that, just put that down there so we can refer to it. So b is 32 and a is negative 16. Remember, b is the coordinate of the middle term and a is the leading coefficient. So I end up with, so negative b, so negative 32 over 2 times a. In this case, a is negative 16. And then I want to evaluate the function for that particular value. So all right. Oh, I need another parenthesis. Okay, so negative 32 over 2 times negative 16 actually turns out to be 1. H, and then so we get h of 1. So 1, and then we need h of 1, so let's come down here. So we have h of 1 will be 128 plus 32 times 1 minus 16 times 1 squared. So I'll go through, evaluate that. 128 plus 32 will give me 160. Subtract 16, so I get 144. So 144. So there are the coordinates of my vertex. The first coordinate represents time, and in fact, what it represents is the time at which we reach the maximum height. So we reach the maximum height at 1 second. The maximum height is the second coordinate. Remember, the second coordinate represents height, so the maximum height is 144 feet. We're following the 5-step process. Don't forget that we do need to check, okay? In this case, for this particular type of problem, how do we solve it? Well, we determined that we wanted to find the coordinates of the vertex, and then we went through the process to find the coordinates of the vertex. So we used the formula, and that's what we did up here, right? That's what we did. So to check it, basically we just need to go back through and carefully check our calculations, okay? So we go through, we do that, we're convinced everything's okay, and we're ready to answer it. So we have determined that the maximum height will be 144 feet. So the maximum height of the ball is 144 feet. So there you go. So there's the answer.